6.1, 6.2D. Okay, this is a three-dimensional graph, if you can imagine seeing this. And how I drew this, in case you want to draw this on your note, I started with the Z, then I went out with the X, out with the Y, so we've got like a perpendicular right here, labeled X, Y, and Z. Okay, and then I note since we're three-dimensional, we're going to bring this X axis out, bring the Y axis out, and then I'm going to draw a shape. So I just pick a point on the Z axis and bring it down, so almost like a parabola. All right, but then I don't want it to look like completely like a parabola, so I'm going to put as if we're looking at some 3D shape. And of course it would go on the other side as well. All right, so since we have it, we'll just stick with this one. I'll erase the other one so I can give you some notes on that. Okay. Remember, we're looking at Z equals f of x, y. Okay? We have something new that we're going to be talking about. But before I get there, I want you to note, if we were to take this point right here, and I was to draw a line in the direction, like a tangent line, that went right on top of this curve. So I'm going to draw in the x direction. So I'm going to draw in the x direction a tangent line. Okay, so it sits on top of that cone shape. All right. We're going to be looking at partial derivatives, and right now what I found was the slope. What we're going to be finding is, I'm going to put it over here, I'm going to call this f of x. It's not really f of x. We say fx, and that means the slope of the tangent line in, how should I say this? In the x direction, the x-axis direction. At some point, x, y, z. Okay? Now let's do another one. Let's go this way in the y-axis direction. So we'll go ahead and find a tangent line to this curve. There we go. And this is Fy. All right? And Fy is the slope of the tangent line in the y-axis direction. At some point, x, y, z. Okay. Now that you know what that is, I'm going to go a little bit further. You'll see fx written as, this is a del sign, and we read this as the partial of z with respect to x. The partial of z with respect to x. These are called partial derivatives. Partial derivatives. Okay? I'll say this again. Partial of z with respect to x. Now when we are figuring this out, and we'll do this in a little bit, what that means is that y is a constant. I'm going to start with x though, because x is on the bottom. We know that to be x is the variable. And why it's a partial derivative is because we're only going to take the derivative of the variables. In this case, y will be considered a constant. Okay, now looking at this one, Fy is the same thing as the partial of z with respect to y. Partial of z with respect to y. And in this case, because y is on the bottom, y is the variable and x is the constant. All right, so let's do some problems that involve this. I'm going to take this away. I know you're looking at new symbols and lots of letters, but it's okay. Just remember we're finding the slope of a line. Okay, so here's a problem. We're used to saying d dx, right? Of 3x squared plus 4x. And how we handled this is x was our variable, and we took the derivative, and that's 6x plus 4. Okay. Well, let's look at now taking a partial derivative of z over the part with respect to x in the equation that they're giving us, yx squared, I'm actually giving it to you, plus yx. Okay. Now remember, x is the variable, y is a constant. So here we have this terminology which just means take the derivative with respect to x. Here this means we have two variables and we're going to take the derivative, we're going to take the partial derivative where x is the variable and y is the constant. Okay, so if we look at this and y is a constant, we're going to keep that and bring the 2. So we have 2 times y, x. All right? And then the next one, which is the constant, y is the constant. If we had 3x, the derivative would be 3, right? So the derivative here is just y, because y is a constant. Okay? Let's do another one. We're going to do the same thing, but now we're going to do it with respect to y. Same equation, so we're going to get a different answer. Okay, y is the variable. This means x is a constant. So if we treat x a constant, and this is y is the variable, then we take the derivative here and we just get x squared. All right? Same thing here. Y is the variable, x is the constant. So x is our answer. Now what did we find? This is the slope of the tangent line in the x direction. And this is the slope of the tangent line in the y direction.